Good evening. Doing good. How are you? How was your day? Diagrams and stuff? You're saying about diagrams? Mm-hmm. Mm-hmm. Okay, let's start with that topic because I was about to start that topic today, right? So that's the main topic for us. It will be like let's say it should be called as force Newton's law, right? And then we will look for circular motion. Sorry. I forgot to share my screen. Okay. Uh, you see my screen? Okay. Can you screen this thing? Okay. So we are covering today force, Newton's law, circular motion, and probably if the time allowed, we will also work on momentum. All right. And I believe because only that's the way that you can understand those topics perfectly fine. Also, take a picture of those questions, MOOCs, so that we can discuss once we are done with the topics. Sorry? Okay. It just shows the mockups. Okay. No worries. We will see how it goes. Okay. First, let's come up with the Newton's law of motion and see how it goes. Okay. Newton's law of motion. As we have seen that motion is there, we have studied motion and the relative equations which are related to um, motion, whether it is linear, free fall, or projectile. Right. So now there are certain laws which guide the whole motion environment. Okay. So the first law, what the first law states, and you have to like remember or try to remember, right, word by word so that there is no difference while understanding it. Okay. Do not use vague sentences while stating the first law, second law, or third law, right? I'm saying is that while stating or while quoting the laws, it should be the exact. You can explain it with your own examples, with your own language structure or sentences, but stating that you should be take care of that it should be the same. So that's why I'm not taking any like kind of uh, risk so to mentioning it here. So you have to take care of that. Okay. So first law of motion, that is also called the inertia law. Okay. So what does it states? By an net external force. Okay. Keyword is net external force. What? Why I am emphasizing it? Let's do some there. So we have an object being of my age and yours. I'm a could like 46 of years age and you are like 18, 19. But assume I am pushing this object from this side with the same amount of force, and you are also pushing it the same object by the same force. Will this force remain static or will move? Why? Net extra. Sorry. Yes. So the balance or equilibrium maintained by the net external force. Okay. The keyword is net external force should be greater in any direction. So if it is 60 here, so the net force will be 60 minus 50. And that will be the 10. So 10 Newton will actively pushing this object and it will move in this direction. And the same will happen if the force from this side will be increased. Okay, this is force Jessica and this is force Mandeep, right? So if my force is greater than yours, then only this object will move. Otherwise, it will stay there. So the keyword is an object. An object remains at rest or moves at constant velocity in a straight line unless acted acted on by a net external force. Okay, now we know these things. We can learn or we can remember remains at rest or moves. Now there are three or four keywords that you have to remember. One is constant velocity, then in a straight line, and the third one is a net external force. All right. So this says an object remains at rest or moves at constant velocity means acceleration is zero. Getting? In a straight line unless acted on by a net external force. All right. This is the first law. Now comes the second law. Yes. Yes. So now we say that what if the net external forces, how much it will be there, so that it will gain some acceleration, or what happened to the mass. Okay. I can give you some example over. I left the example section over here. Example is a ball on ground won't move until you kick it, right? A rolling ball, or simply, or a rolling ball keeps moving keeps moving until friction stops, right? This is the example. You can say that if we don't touch a ball, it will stay there. And in my childhood, my mama says, "Where is the, let's say, the knife in the kitchen?" And every time we will say, it should be there." Because we accidentally move it somewhere and place it somewhere and we forgot. We always say that it should be there. But the first law says no. Until someone has moved it, it will stay there. It should have stayed there. It's not there, that means somebody has moved that. Okay. Now, what the second? Yes. What does that mean? That means, so the acceleration, it states, the acceleration of an object, of an object is proportional proportional to the net force. Again, the keyword is, I should have mentioned it in some other color. Net force, right? Proportional to the acceleration, proportional. Sometimes my lines are straight as an arrow, and sometimes I don't know what happened. Okay, to the net force, and and inversely inversely proportional to its mass. Inversely proportional proportional to its mass. Okay, so this is the statement. that I want to say, that now you are asking what is inversely proportional. Okay. Okay, let's see. So first is it is saying, it's stating that acceleration is proportional to the net force. I always say F net. Okay. And the second one is saying that the acceleration is inversely, sorry, acceleration is inversely proportional to its mass of the object. Okay. So inversely proportional means if if the acceleration in, so if the object is light, acceleration will be more for the same f net. Okay. And acceleration with the proportional to f net means the more the force, the more the acceleration with the same mass. Directly proportional to the f net and inversely proportional to the mass. So here I'm saying with same mass, right? And here I'm saying with same net force, right? For example, if there is a ball, lighter ball, I put it the same force, right? And there is a heavier ball which I throw with the same force. Who will go further? The lighter one, because it gets the more acceleration. So the lighter, that means less the mass, more the acceleration. That means that is what is meant by inversely proportional. Sorry. Yes. Okay. So, sorry. Yes, that's the 1 over m. So if it is same, that means a should be proportional, like it is proportional to the f net. The more the force, more the acceleration. If it is inversely, so what happened is, if we map the both the equation, which will gives us the exact formula, f net equals to ma, right? From here, if I say a equals to f net over m, got it? So for example, I have two masses. One is m1, which is lighter than m2. What happened to the acceleration relation to a1 and a2? That's the question. So with the same f net, right? So for this one, a1 will be f net over m1. True. And then, yes, it's the mass. And a2 is equals to f net over m1, over m2, right? So now let's say which will be greater, because we need to find out what will be the and see. Take an example of m1 equals 1 and m2 equals 2. Let's say gram, right? And gram. So this is going to be a1 equals f net over 1, which gives us a1 is equals to f net. right? Here, what will happen? Tell me. Fnet over 2. So this will gives us. So what happened to the acceleration? No, no, no. A2, if we compare now A1 with A2, so A1 is Fnet and A2 is half of Fnet, right? So that means when the mass is low, the acceleration is more, right? So that's what the inversely proportional means. So it is opposite. If we increase the acceleration, or sorry, if we increase the mass, acceleration will decrease. If we decrease the mass, acceleration will increase. That's the inverse. So if m1 is less than m2, that means a2 should be greater than a1. Oh, sorry, a1 is greater than. Any question now? No, no, you have to just mention it. Okay, the acceleration of an object is proportional to the net force and inversely proportional to its mass. So A is proportional to F net and A is inversely proportional to 1 over M. Okay, so this is how we portray, how we can say mention the inversely proportional relation between two quantities. All right. It's not like this only. If any quantity which is inversely proportional, that means it is 1 by that particular quantity. All right. So by this, and this will only happen. So when it is true with same mass, when it is true with same net force, that means we are making one thing constant, right? Yeah. So in this case, we are making net force constant, and in this case, we are making mass constant. So this is where we get our equation number one important. It is not F equals ma as we have seen in many books, right? It is the F net, and this particular term will make the differentiate between understanding and not understanding the whole scenario of forces. Net, yes, definitely. Overall, yes, that's the net force because in for an object, as you have seen that there are many forces acting simultaneously. Which force that we have to consider? That's where we are getting to do our free body diagram, right? That's we will see the F net thing, how to calculate it and how to move forward, how to put in there. But this equation will remain the soul of our questions like that, and we have to mention that this is the net force. All right. Now, yes, 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 yes. We will come to that. We will come to that. Right. So that's m F net is equal to ma. That means, and also what you are saying, that is the weight. Mg is the weight. So m is the mass. When it is acting under a gravity, right, it becomes weight. So the weight of a particular object is m, the mass, times gravity constant. That's the reason. So F net, So if a body is like hanging somewhere, what is the net force which is acting on it? So there is a tension between the string and that particular object, and there is a gravity which is pulling it down. Sorry. So that's the mass, na. For example, let's wait. Okay, I will give you some examples. Let's finish the topics first. Okay, and I will show you what the actually. So we haven't, so don't confuse yourself with what you have seen, because we haven't done that yet. Okay, so if just for the sake of it, I must say that if a body is hanging, or if a body is staying on, for example, if there is on a surface itself, let's say there is a surface, right? And a box is there. Okay, block of, let's say, so now it weighs, let's say, um so when I'm saying weight, right, when I'm saying weight, right, so weight is the force, weight is the force which acts on a mass in gravity. Okay, so then because it's a force, that means if we have a m as in mass, what will be the acceleration under gravity? G. That's came the F equals mg. Okay, so that's the weight that we are talking about. In any time when we have a weight, or some question is talking about the weight, that means it is talking about this thing. It's talking about a force which is acting on that object under some gravity, right? So every time, so why it's not moving, let's say why it is not moving, because the downward weight is equal to the upward weight, is equal to the normal weight, you can say, the normal force. So that's why there is no movement, right? So then we have, so now when we are going to study the free body diagram, we will understand the concept of system and the forces acting on that acting on that object, or on the subject. Okay, all right, do one thing at a time. No, no, no worries, no worries. We will cover it. It's not like that. We will cover up all the topics, all the questions. It's something that we should have done a bit earlier. You came at the last stage, but I need to do some crash courses for you so that we can cover all those things, right? But give me some time to come to that point. I'm going there. I will cover each and everything. I know that you have studied all the full course, but there are concepts, you can say, there are understanding of those concepts or those values or those formulas that are there, and still you do not know how to use those formulas to solve the equations or the questions that has been asked in the question paper. So that confusion will be covered once we understand the statements, once we understand the concept, once we understand the formula, right? Okay, now come to the third law. What? Yes. So the third law states, for EVERY, every action force, action force. Now, what is they are saying? For every action, it's not for for every action force. It's not just the action. Okay, the keyword is action force. There is an equal and opposite reaction force. Reaction force. Again, the keyword is force. That's what we forgot every time, right? Yeah, so I have already explained the example here. And for this, though, what will be the what will happening, right? So let's take an example, and that's what you have, I think, felt so many times before. When you push the ground while running, the ground pushes you forward with equal force. Forward with equal force. Okay, so that the when we push the ground, that's only that we're moving forward. All right. So let's go with some questions. I'm just taking some arbitrary questions. Okay. A block has a net force of 12 Newton. So Newton is the unit of force. Okay. And a block has a net force of 12 Newton and a mass of 4 kg. And a mass of 4 kg. What is its acceleration? Can you solve it? Okay. So first, what you tell me, I will write it on. First, what we do. So first, we do what is given, right? Again, ne- is equals to 12 Newton. Then it is gas is equals to is equals to 4 kg. We need the acceleration. So we use Fnet equals ma. Yes, very good. Hmm. Very nice. So now put the values. Lovely. You are now good to go with the merit. Okay. So see, once you have a clear image of how to attempt the questions, see how it is easy, right? The correct what is given, what is asked, what formula it is, rearrange the subject, put the value, state the questions, mention the unit. Got the answer. All right. Cool. Okay. So let's uh, give you some questions. Okay. A hockey puck slides on ice with negligible friction. Why does it keep moving without needing a push? Okay. Question. Mhm. Yes. Exactly. No, that force means velocity stay constant, right? A hockey punk slides on ice with negligible negligible friction. Why does why does it keeps moving keep moving without needing a push? Right. So the answer will be first law of motion, which states, yeah, no net force means velocity stay constant. You can write the same statement as well. Okay. Yeah, you can state that at constant velocity in a straight line, unless acted on by a net external force. You can state that. If you remember, you can write it down. Or you can say because there is no net force, means the velocity stay constant. All right. Second law, we have already done it. Uh, as opposed to friction. Oh, okay. Now, the question for let's see how it goes. A 5 kg box is pushed is pushed with 30 Newton forward. Forward. Friction equals 10 Newton backward. Backward. Find acceleration. Now here comes what we need to do. First of all, what is given, right? Okay, you saying mass, I'm going with you, okay? You just know mass equals 5 kg. Then mhm, force, friction is 10 Newton. And then what we need to find? Acceleration. Okay, now tell me how we can move forward. Why? Mhm. Because the formula fits for asking for net. Okay. Yes. So because we know is equal to F net equals to MA, which leads us to calculate the F net first, right? And if you want to rearrange, that will be a nice thing. F net over M. So we don't have F net. So what will be the F net? Why it is going to be uh, 30 Newton forward and 10 Newton backward? This is where our body diagram comes in. I will explain in detail, right? We had an object, right? There is a weight, 5 kg, right? And there is a normal force is also acting upward because there is no vertical movement. Okay. And there is a 30 Newton forward and there is 10 Newton friction backward. Okay. In which direction it will move? In this direction because, yes. So, yes. No, 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 no. So, see, here it comes because, so what will be the net force? Where is the actual direction will go, na? Right? So, which is going to pull it? The 30 Newton one because the friction is only 10 Newton. Okay. So, that means F net is going to be the F forward equals to 30. Oh, sorry. F forward minus F backward. Okay. Which leads us to 30 minus 10, which gives us 10. Therefore, A equals F net is 20 over 5 equals 4 meter per second square. That will be going to the answer. Got it? Okay. That will be in electricity, right? No, no, we will use that too. because there is a question which says the droplet, right? Oil droplet which is inside the uh, uh, charged plates. Yes. So what will be the total number of charges in that particular? So we have to see that the weight of the electrons, and then we have to see the total number of charge, and then we have to multiply by the singular electron charge. That will gives us the total number of electrons in that particular droplet. Right? Sort of. There are many, but this is. I mean, these some they will around move around with this one. Hello, Guru the serial. Okay, sorry about that. So a swimmer pushes backward water backwards with her arms or with his arms. Explain why he or she moves forward. True. So what will be the action? Arms pushes the water. What will the reaction? Water pushes the swimmer forward. Okay, that's cool. Okay, now come to the next topic. So more or so, when we are considering force, we should be doing it in a holistical, the eagle eye view when we are thinking about force. So it's not just the mechanics; it also comes in electrical forces, right? There are many kind of forces that are acting. There are a much more broader area when you are moving towards year 13. It should be considering the forces between the heavenly bodies, like the gravitational force, how, yeah, and the forces between static charges, how they had been calculated. So it's everywhere. How then it comes to the power, energy, work, kind of thing. That base. So first we started with the motion, then with forces, then we will moving to the other kind of motions, that is circular motion, and we have also done the momentum, right? And also the impact, impulsions, compulsions, and then we do have like power. So these are the topics will be cover up over the period of time. So there is no nothing to hurry about, and we can discuss it further. So mainly the topic says, now come to the next topic. So more or so, there is no such confusion now, I believe, regarding the forces, right? The term is net force. Yes, and then action force, reaction force, right? And then you have to think about the proportional and the inversely proportional. That's it. Net external force, yes. Yeah, net external force. True. Now come to the next topic. We have circular motion. Okay. So what the circular motion means, when an object is moving in a circle, almost in a circle. Okay. So what does it happening is, its velocity is changing the direction at the every tangent of the circle, right? So the change in velocity, what is change in velocity? The rate of change of velocity. I'm asking what is the rate of change of velocity? As I said, so rate of change of um, distance is velocity, right? Rate of change of velocity is acceleration, right? So if there is an acceleration, there must, so because now in the circular motion, what is happening is velocity is changing with the constant speed. The speed is constant, but velocity is changing. Both terms are here. Speed, because the value of the magnitude, you can say, is the same, but the direction is keep changing, right? So if the direction, if we consider if, because we know that velocity is not just the speed but also is the direction, that means the velocity is changing, right? And because the direction is changing, there must be because that leads to a velocity in change, and which leads to acceleration that called centripetal acceleration, which requires a centripetal force. Got it? Okay, let's see. I must state here, when an object is moving in a circle, right, at constant speed, its velocity changes direction, changing directions every moment, every moment, right? So this is the concept of a circular motion, right? Because there is a change in velocity, right? Whether it is direction or the magnitude is the same, but the direction is changing. This means there is an acceleration towards the center. There is an acceleration towards the center. This called centripetal acceleration. And because there is an acceleration, it requires centripetal force. It requires centripetal force. Perfect. So everywhere there is an acceleration, there will be a force, right? Because this acceleration is happening in a circular way, and it is something like, acting like this thing. Yeah, so the acceleration will moves around, okay, and keep it round. So then we came to know that, because now the keywords is velocity changes direction. That's why we have an acceleration towards the center. That's the direction, which is called centripetal acceleration, requires centripetal force. Three, four keywords. Velocity changes direction. So main is velocity changes direction. Okay. That's why, that's why there is an acceleration which is called centripetal acceleration, and that's because there is an acceleration which is required, and so that requires centripetal force, right? How we calculate the centripetal force, which gives us Fc equals mv square over r. Okay. Now, when we compare this with our Fnet equals ma, we can say a equals v square over r. This, this is the acceleration, centripetal acceleration, and this is centripetal force. All right. So now the key points from this explanation is, oops, key points is one, the force is always directed inward. Okay. So the direction of the force will be always be inside, inward. Okay. Second point, without it, objects flies off tangentially. So what will be the direction of the trajectory? Yes, I will explain you. Without it, the object flies tangentially. What does this mean? If we stop the, for example, if we try to stop this, the tangent of a circle means in this the same direction. If I lost the control over here, it will move in this direction. If I lost the control over here, it will move in the direction. If I lost the control over here, it will move in this direction. Okay, so that's the tangent. Tangent means this one. If there is a circle, let me draw something if I can see. Oops. I don't know. Okay, never mind. So tangent means the edge of the circle. Okay, so if, let's say, if this is a half circle, so this is the tangent, the line which is touches the the uh, circumference of the circle. That's the tangent, and the line which draws perpendicular to it is the normal. Okay, so that's what I'm saying. Centripetal. Yeah. No, I'm saying that you are confusing with the notion. The centripetal force is, so when I'm talking about in the motion sense, right? When I'm talking about a circular motion, this is the centripetal force which is acting inwards. But I'm talking about geometrically to make you understand what is the tangent. There must be a line which is perpendicular to that particular tangent is called normal. Okay. Okay. Let's see some examples if possible. Oops. Okay. Satellites in orbits. That's the best we can say. What is moon? What is moon? Moon is a natural satellite to Earth. Okay. So the same thing happens there too. Right. So that's why. Okay. Uh, you remember some names of Saturn's moon? Okay. No worries. No worries. No worries. Okay. Cars turning bend. So there in India, I'm not sure what happens here, but back in India, in rural area, when there's some like cultural fair will be there. So there is a hell. Uh, uh, there is a well of death. Right. And in that, so it's something I'm not sure that if I can show you, but let's give a try. Hmm, I can give you an example over here. If the, I'm sorry, well of death, India. So you can see this. So this is where the centripetal force acceleration will work. Right, the car is moving on the edge or the circumference of the circle with the speed such that its weight is cancelled up by the centripetal force. Okay. Yes, not the speed, the weight, because if the weight is not cancelled, it will steep down towards the center, right? So that means if it is not falling it, that means it's not it's the canceling the weight itself. So the movement, you can take an example of like if you fill a small bucket, have a rope in it, and just move fast enough that no water will spread up. So that's the best example for centripetal force which is acting. Yes, it's fast. So we have seen this in the in our equation, right? So it is calculated in such a way that it is acting like uh, the velocity and the circle, the radius of the circle is also calculated with the mass, so that we can see that how much speed that we needed eventually, right? If we know Let's say, I think if it is mentioned with the g equals to v square over r, and we must say, I will give you some more videos to watch it out to how it is looked out, so we can calculate the velocity, minimum velocity that they have to maintain into towards the edge of that circumference. Okay, so that's the thing. Okay, where it is. Okay, so car turning bends. There is also a good example that on highways, and there are much more, where the speed is considered. You have seen some motorways which are tilted inwards. You can feel the tilt while you are taking a turn, right? So there is a certain type of angle which is produced so that it will the speed will cancel out the weight, otherwise it will can be leads to an accident. All right. And the other example is washing machines spinning clothes. Right. Okay. So if we go for like example, let's have an example. You can find it easy with this one. Okay. A 1 kg mass moves in a 2.0 meter radius, right? Circle, a circle which gives us force to 8.0 Newton. Find the speed, right? So let's do the way that I have taught you. What is given? The mass 1 kg, the 2.0 meter, 8 Newton. Okay. Now what we are looking for? We we are looking for. Yeah. So mv square over r, which leads us to change the subject. So first change the direction, is equal to fc, which leads now it can be like multiply both by r, right? Both side. So it will gives us mv square, sorry, mv square equals to fc times r, right? Now we can divide both side with m, so that will gives us v square equals fc times r over m. Now we need the v, which is, we are taking root square from the both the side. Okay, r over f. Now put the values. So root 2 times 8 over 1, which gives us root 16, which gives us 4 meter per second. Got it? Okay. So that's the simplest one. So if you can get the gist, you know the formula, what is given, what is asked, change the subject, you will definitely get the answer. No yeah. For the circular force, we are mostly using this one. Okay. Okay. Now, question. Okay. Now the question says, uh, it's going to be the same, right? But they have changed some kind of wording, you can say. Let's see. A zero point 0.2 kg stone tied to a string is swung at 5 me 5 meter per second. The string can sustain a max tension equals 25 newton, right? So find the smallest radius before breaking. Before breaking. That means we need to find now the radius, because the breaking means it is exceeding the tension itself. So that's only if we have like a string with two ends. If we keep on stretching it, at some point it will break, right? So up to what we can stretch it up, so that will gives us the smallest radius. The formula will be the same, but yeah, for can we do it now, or you can do it? Okay, let's see what is given. M point 2 kg, right? V equals 5 meter per second. The FC is 25 Newton, right? What looking for? R. So the formula says F equals mv square R, which gives us, if we multiply both by R, or just rearrange the FC and R, it will gives us R this side, right? It will gives us m v square from FC. Now we can put the values. and we get the answer. Okay, R equals 0.2 times 5 square over 25, which will gives us 25 cancel 25 is equals to zero point 0.2 meter. Okay, all right. So again, if we have like a car of 1000 kg turns around a curved radius of 50 meter at 10 meter per second square, what frictional force is needed? So now the frictional force should be equivalent to the centripetal force, so that it cannot be uh, skid up on the curve, right? So that means on the curve, I'm just stating this statement: on a curve road, the friction force should be equal to the centripetal force. Okay, now that means F frictional equals to F centripetal, which is equals to mv square over r. Okay, now there is some conceptual question can be asked, and that we need to answer that too. Why do astronauts in orbit feel weightless? Right. So why do they feel weightless? It is something to do with the free fall, right? Gravity has like a center. The centripetal force is provided by the gravity. They and the spacecraft fall together. So there is no such pull actually, which is giving it towards the thing, right? So if I should say that because continuous, they are in continuous free fall, centripetal force is provided by the gravity. So they and the spacecraft fall together. Okay, alrighty. So now the next will be the free body diagram. Do you want to continue or it's okay? Yeah, sure. Okay. Now, free body diagram. Okay. What is a free body diagram? Phi F. BD, a free body diagram, shows all the forces, all the forces acting on an object. Okay, acting on an object. So to draw that, these are the steps. First, draw object as a dot or box. Draw object as a dot or box. Second, draw arrows for each force. Okay, draw arrows for each force. Right. Third one is label each arrow. Label each arrow by gravity, normal, tension, friction, or applied force. Okay, you can also do this thing if, like, it's not essential, but still, length of arrows, length of arrows is equals to relative size of force. That's, you can do that, but it's not essential. It's desirable, it's not essential, right? Yeah, it's just to make clear that which force is more and which force is less, right? So now the rule is net force is equals to sum of all forces, right? If force balance, if forces are balanced, then acceleration should be zero. That means if the force is balanced, there is no acceleration, right? If there is no force, if the forces are not balanced, that means there is an acceleration, there is a movement in that particular direction. Okay, now let's take an example. Okay, I'm giving some questions so that we can do it. Okay, it's no, we are not solving anything, we are just mentioning, or we are just trying to write it, or draw some free body diagram. Okay, so the question says 10 kg box rests rest on a flat table. On a flat table, right? Thank you. A person pushes it with 40 Newton force to the right, to the to the right, right? Friction is 10 Newton, right? So how we are going to draw this one? That's the question. So let's say I will try to use different color so that we can differentiate between the forces. So this is our box. Can you see that? Okay. Okay. Now, a person pushes it with 40 Newton to the right. So there is a force. There is a force to the right. That is 40 Newton. So if there is a force towards the right, there must be a friction on the opposite side. What is it? The friction should be on the opposite side, right? So this is the force friction, which is 10 Newton, right? So now it says 10 kg box rests on a flat table. So there will be a weight also going downwards, right? So there is a weight which is going downward. So now what is a weight? As I already told you, what's the weight? Exactly. So weight is a force. You have to remember that, okay? So the weight equals the force, which is mg. Okay. I'm taking g as 10 meter per second square. Right. You can take g equals 9.8 meter per second square, which is almost equals to 10 meter per second square, right? In some calculations, we can also use approximately pi square. That's an interesting thing, right? That's very interesting to solve some questions, maybe in some other competitive examinations, where g equals can be pointed out as approximately pi square, if because the pi's value is 3.14, right? And if you run the square, it almost give you 9.6, 9.7 kind of value. So it gives, we can take it as it is. Okay, good. So the weight now, To calculate the weight, we should have the mass. Mass is 10 kg, right? And then there is a gravity, which is 100. So it will be 100 Newton. So the weight will be 100 Newton this side. Now, because it is resting, that means there is a another force which is acting on it. Sorry? Wow. Okay. We have used this before. Okay. Okay. First, we do something like this. Okay. So there is a force which is acting like this. Then there is a force which is acting like this. That is friction. Friction is always against the motion. Okay. And if there is a weight, so now there is, because weight is always on the downward side. Okay. So that's the weight. And because it's not moving downwards, it's resting. That means there must be an equal and opposite force which is acting upward. That is called the normal force. Opposite to weight, yes. I should have mentioned this here so that it will be give you some notes. Normal force act opposite to weight. Okay. So it is downwards, it will always be upward. So now the normal should be equals to 100 Newton. Now you are wondering where the 100 Newton comes up, because it is the weight, right? And weight we have already calculated over here. This is the weight, right? What is M here? M is 10 kg. I'm taking G as like 10, right? Yeah, yeah, you can take. Definitely. Definitely. If you want to take, you can take 9.8, which will gives us 98. Okay? Will gives you 98, and this will again becomes 98. Your confusion shouldn't be there. They should have respect that. Okay. Yeah, so that's important thing. Okay, so normal force. Now you understand the free body diagram, right? So this is how. Sorry. Yes, definitely. So if now, uh, let's see, that's the inclined plane. Okay, now before moving to that, we can say, let's take a question of person in the elevator. Okay, now, so again, we are doing some kind of thing which is whatever it takes. Okay, so person in elevator. A 60 kg person is in a lift accelerating upward at 2 meter per second square. Okay. So now what will first let write it down the steps so that it will make clear. So represent the person as dot. So that will be our system. Okay. Secondly, weight will be equals to W will equals to 60 times 9.8, right? That equals 588 down, right? So that's the weight. Five 88 Newton downwards, right? Then third one is normal reaction force. Normal reaction force. Will this be less or more? Okay. I'm just putting it less over for this one. Okay. Less than weight. Okay. Fourth one is net force. Net force will be F net equals to, we know net force is equals to always MA, right? Which is M, we have 60. Now we have 120. Oh, sorry. A is 2, right? So I'm just writing it down here again. M equals 60 kg. Then A equals 2 per second square. So that will be 2, which gives us 120 Newton, right? So what will be the normal reaction force then? We- Yeah. So we know in the system, F net will be, because it's now moving upward, right? So it will be like the weight plus the normal. That's what I'm saying, right? So now we know the weight, we know the net. We just want to know what is will be the normal because we don't know at this moment. Okay. So because weight and normal are opposite, I have to take one of them as negative. Okay. So let's consider weight as a negative. All right. Because it is down and normal is up, I'm taking up as a positive and downward is negative. Okay, I'm just mentioning it because weight is down, downward direction, and it is opposite direction to the normal reaction force. To represent this, consider weight as negative. Okay, so then means F net will be the negative of the weight plus the normal, right? So we don't know the normal reaction force, we can say. Then normal will be F net plus weight. So that will becomes F net is 120, right? Plus weight is 588, which gives us which gives us 708 Newton. So now tell me the normal reaction weight is more or less? Huh? So the normal reaction force is 708 and the weight is 588. 588. It's more, right? So it should be more. It should be more. Why? Now the question arises. I believe that you got confusion with the concept that when we are in acceleration, we weigh less, right? Or we feel like a bit lighter, right? Okay, that because the net force that we have on our body is just 120 instead of 588, right? We are feeling 120, so that's the way that we feel lighter. Okay, so the normal reaction force is always like more when we are going upward, and that's the true one because we are going upward, right? Who is pulling us up? Against the weight we are going upward, that means the normal reaction force should be greater than the weight. That's why I'm moving forward or upward. Okay, the acceleration, remember, if there is a gap between forces, then only there is an acceleration. If we are moving upward, that means there is a gap between the forces, between the weight and the normal reaction force, right? So if it is more, then only we are going more upward. If it is less, then we are moving less. We are moving downwards. Okay. So now come with the free body diagram. Let's see. Again, represent the person as a dot, right? The downward will be the weight only, right? And the upward will be the normal. There is no forward or backward forces because we are moving only upward and downward, right? We have already calculated this 588 Newton, and have calculated this normal as 708 Newton, right? So that's how we are driving with the vertical one. There only be like two arrows which is acting on the object or the subject. Okay. Now comes up with the object on an inclined plane, right? Okay. Object on an inclined plane, right? So the question says a 5.0 kg block slides down a smooth incline a smooth incline at angle 30-degree, right? So now let's do something which is being we haven't done it before. I'm drawing a incline slope. So let's say this is an incline slope, right? Okay. And this is the block. Okay. Now this, oops. Yes. So this is the weight, right? Which equals to mg, right? And this is the nor- normal, and so this will be acting here, and let's see, this one is acting here. Okay, now this is our w, let's say. So this is the theta, the angle, right? Hmm. So this is the theta, right? So the theta is going to be 30-degree. This is going to be the cos theta, and this is going to be the sine theta, right? So this is W, this is W cos theta, that is reacted to the normal, right? Sorry. So because it's not moving up in that direction, it's moving in this direction, right? And it's smooth incline, so there is no friction, right? So we are not putting it as a friction force in this direction. So it's moving in this direction. That means we have to calculate this thing. So which force will be acting towards it opposite of it. So it will say that how much force that we need to make this block, or what will be the friction to make this block stationary at this. So it should be equal to the w sine theta again. Sorry. Need to be same. The read the question first, right? So if it is says that calculate the sliding force, that means that we have to calculate w sine theta. Anyway, if it's asking that what will be the minimum friction force we need, so that, or the block should be the slope, what friction do it has to make the block stationary, right? So again, we have to see that because it should be like it should be, the friction should be on the opposite direction. So it should be equivalent to the force, the force which is making it slide downwards, right? Okay. So if I am done the correct thing, yes, 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 yes. I'm just saying that resolve it into perpendicular slope. Mm, I'm just checking that what will be the 30-degree angle. If this is theta, then perpendicularly this need to be theta. Okay, now I get it. So if, let's say I need to change it a bit. Okay. So again, if we have like two parallel lines, why I am just thinking, and if there is a line which is cutting this side, right? So just imagine that these two lines are parallel, right? So if this is the 30-degree angle, right? This angle need to be the 30-degree angle. Mm, this angle should be 30 degree. This one, this is theta, then this must be the theta. Yes. Okay. And this line is cutting that thing. And okay. So now that's what I'm thinking. So here theta is going to be 30-degree angle. And this is again, now this will be the W cos theta, and this will be the W sine theta. We need to check that what theta they have given, or what the angle they have given. Okay. If they have drawn it, so then it will be okay. Otherwise, sometimes it was given that this angle was also given sometimes, right? If this is given, then we need to calculate this angle first. That will be 90 minus this angle, and then we will see the The slope will be always cos theta, and the perpendicular will be the sine theta. So again, if it is slope, it should be going to the that end. It's not. It cannot go upward. If it is sliding, it's going to the downward only. Yeah. Hanging mass. That should be done. Okay. Now there will be some questions which has been asked in the past question. We will do tomorrow. Okay. All right. And then there is some question for the equilibrium with the hanging objects, asking for the tensions, and we are good to go with the circular and the forces. Right? We have covered. Yes. 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 The questions can be done tomorrow. Mm, one thing which one thing will be let the part C part, the impulse formula, impulse and the momentum. Okay. So that's will be included in the tomorrow's lecture. All right. So I think that we have covered forces and the free body diagram, and also we have covered the all the three laws related to it. Some questions we have seen, and we will see how these questions are relating to the questions which had been asked. I will suggest you to start doing some of the Skypad related to this topic. Okay. And we will see if you have any. I believe that now you are have a pretty much more confident in getting to the formulas, getting to the rearrangement of the variables, and trying to solve them. Yeah. Okay, good. All right then. uh See you tomorrow. Yeah, I'm let's do it straight away. Okay, let's do it here. Save. Jessica, 6th of October. Mm, good. And send. Okay. See you, kiddo. Tomorrow, 6:30. All right. See you. Bye.